So that brings us into the use of this for something else, because nobody had sugar beets on their list. The closest one to that might be using a technique like this would be the person with potatoes, but only if they desiccate them early. If they allow them to dry naturally or die naturally, then using it for green manure really isn't much of a use. So we use it mostly, we use these techniques mostly for the sampling. There's two different types of sampling. One is the grid, which many of you are familiar with, and then the zone sampling relies on something logical to reduce the number of samples in the field and give some meaning to the patterns that you see. How I got into it, I came from a grid sampling environment in Illinois, and I came up here and did a grid sampling study. The first year, using quarter-acre grids, I got this nice nitrate map, and I think it looks like a horse head. Some people think it looks like Joe Camel, the old logo for one of the cigarette companies. So, but it is kind of cute, and I thought, well, that's cool, but I'll never see that again. But the very next year in sunflowers, here's Joe again, here's the horse head again. So the patterns were stable between year to year, and this was a aha moment for me, and I started to investigate the zones. And what I found is that these patterns are stable between years, and a lot of them, at least in our area, are dictated by topography, because water moves, but it always moves to the same place. But there are other tools that a person could use. One of these is electrical conductivity sensor. This is a picture of the one developed and marketed by Verus out of Salina, Kansas. Current comes from the outside disk to the interior disk, giving you a deep EC reading, and then there's a current that goes into the interior disks that gives a shallow EC reading. So if this is configured correctly, and this isn't configured quite correctly because the GPS is on the cab and it should be on here on a pole away from the current, but as it's going through the field, you get a GPS reading, a Latin long or UTM, whatever you're set up for, and then also a shallow EC and a deep EC. Some of this is related in some parts of the country to the depth of a limiting layer, like a fragipan or a clay pan of some kind. Sometimes it's related to differences in clay content of the surface soil. Sometimes it's related to moisture, differences in moisture, which sometimes are related to the other two things I mentioned. And then if you're in an area with soluble salts like we are, it can give you a good idea of where those soluble salts are. Organic matter also plays a role in what comes into the cab. We use it as a pattern detector because we have differences in clay, differences in soluble salts, all kind of swirled up within the field. But others around the country use it for specific things, and so using it and compare it to things that you normally see would give you a good indication of what you could actually use it for. Excuse me. All right. This is another instrument that's used in the same manner. Electricity and magnetism are related physically, mathematically. This is a better picture of it down here. Is a EM38. It's marketed by a company up in Canada. This is it on a sled. It's really nice if you have rocks to use something like this, because the Verus, the disc just eats it up. It gets dented up pretty well. But this doesn't enter the soil, and so you can walk across the field, set it down, put it on the sled, get continuous readings, link with GPS. Or if the field's muddy, which I've done that a couple times, where you can't get in with the Verus, you can gingerly walk across the field with the EM38 and get similar readings. So I find the patterns that you get with the Verus and the patterns that you get with the EM38 are very close to the same. The remotely sensed images, we'll have different examples of that as we go through. Yield data, yield monitor data is taken by a lot of people. I've taken yield monitor data from corn and canola and all kinds of crops. And how do you manage the years of data? I like to see them used for zone delineation by developing something called a yield frequency map. And I'll briefly describe that, and I have a circular on my website that shows how to do that also. So if you want to look at that sometime, you're certainly welcome to. They're free. So what we do is if you take a field and you decide that maybe you're going to make an 80 by 80 grid out of it, let's say it's a quarter section of land and you want to make an 80 by 80 grid, you do so, and each of the values for the yield is averaged within each of those 80 grids. And then when you go from year to year, you add those up. Well, how can you do that when you have 200 bushel corn yields maybe one year and 2,000 pound dry bean yields the next year, and then you have another crop the next year? What you do is you normalize the data. So if your yield ranges from 0 to 200 bushel, you normalize it so that all of a sudden you have something like 0 to 1 or 0 to 100. You put it on the same scale. So divide all your numbers by your highest yield. So whether you have canola or whether you have corn or whether you have soybeans or whether you have wheat or whatever you have, it's all normalized into the same scale. Then once you do that with each one of the grids, then you can add the grids together and you come up with a yield frequency map that looks like this. This is the 5 or 6 years of corn data from the Oaks field in southern North Dakota. And we have areas in the lighter colors that have consistently low yields. You have areas in the darker colors that have consistently high yields, and then you have the areas in between that flop back and forth depending on what the moisture is. So this is pretty powerful, and the delineation patterns that we find are very often related to things like topography. You can see them on the satellite images over years. So I would recommend not using a single yield map, but to put your maps together so that you have a stronger basis for zone management. There's a few people that use soil survey, but I really discourage it unless you find that for some reason yours really describes what's happening. The soil survey is only useful, I find, if it maps at what I call a order 1, and that's mapping things that are 1 acre in size or larger. Most of the published soil surveys, and the one that you can peel off the web, are surveys that don't map anything less than 2.5 acres in size. And to do that, they lump a lot of things together. This is an example in the southeast part of our state of a field we've looked at. The nitrate map is down here in the lower right-hand side. The soil survey published looks like this on the left, and the order 1 that I had commissioned just for the study looks like this, which looks like this. So the order 1 is the one that looks like what's happening on the field, and the order 2 that you get from the soil survey file or the soil survey book really doesn't. So again, it's something I hardly ever look at when I'm making up zones. So I've described many different tools to use. Focusing here on in this series on satellite imagery, there's also the aerial imagery, topography I mentioned, yield I mentioned, order 1 soil survey I mentioned, and the EC. In this particular year, in this particular field, the yield was the best and the order 1 soil survey was the worst. And then the very next year, the order 1 soil survey was the best, and aerial was horrible. In topography, yield were kind of in the middle. So what in the world do you do? Which one do you choose? Which one's going to work out for you? And if you choose only one to work with, but it's satellite imagery or anything, you're kind of rolling the dice that it's always going to be useful for you. So I would recommend putting at least 2 together. When we did this in this field, we just example here, topo plus the EC or R is consistently up around 0.5, and I can tell you when you're working with anything precision ag, this is a pretty good number. So putting things together increases the correlation between of what's actually out in the field. So I really recommend more than one data layer, and I don't care which 2 you use or 3, but just use more than one.